Hello students, welcome to this 15th lecture of the series of lectures on three-dimensional geometry. Here we are going to study bisector plane of angle between two planes. So if we have two planes given along with their equations, then there is some angle which these two planes make with each other. The plane which is bisecting this angle, there is a plane which is actually bisecting this angle into two parts. That is, this is half of this and this is again half of this. So there is a plane which is something like this and it is bisecting the angle between these two planes. So these are the two planes which I have. Let me show you like this. These are the two planes and there is a plane which is bisecting the angle between them. So there is a plane like this and there will also be another angle between these two planes. This is one angle. If we proceed here, this is another angle. So there will be a bisector here also. So there will be two bisectors of the angles between the planes because there are two angles. One is this, and if you extend it here, this here, so you will find there is an angle, this one also. So there is a bisector here also. So if one angle is acute, another will be obtuse, and if this is 90 degree, then another will also be 90 degree. So basically there will be two angle bisectors of the angle between two planes. So if we see that this is u equal to 0 and this is v equal to 0, these are the two planes, u equal to 0 and v equal to 0, or we can say that u is actually a1x plus b1y plus c1z plus d1 equal to 0. This is the first plane, and another is a2x plus b2y plus c2z plus d2 is equal to 0. This is the another plane. So any point on this red plane, which is the bisector plane, will have the distance from this plane and from this plane will always be equal. That is the property of the angle bisector in two-dimensional geometry also, that any point on the angle bisector is equidistant from the two lines. Here actually these are two planes. So all the point here will be equidistant. So if we take a point h comma k comma l on this bisector plane, then its distance from this plane will be actually a1h plus b1k plus c1l plus d1 mod by root over a1 square plus b1 square plus c1 square. This was the result which we studied in 12th lecture. Distance of a point from a plane, and this distance is equal to the distance of the point from this plane. So that is a2h plus b2k plus c2l plus d2 modulus by root over a2 square plus b2 square plus c2 square basically. So actually these two are equal. The length is equal from that bisector plane to any of these two planes. Now when we find the locus, we replace the point by a variable point and we consider that HKL are XYZ. So we can say that finally A1X plus B1Y plus C1Z plus D1 by root over sigma of A1 square here, and on the right hand side A2X plus B2Y plus C2Z plus D2 upon root over sigma of A2 square. Now there is one more thing, there is a modulus here. So when you will eliminate modulus from both the sides, there is a possibility that they can be of the same sign or they can be of the opposite sign. In that case, there is either a plus or a minus over here. So actually this is the equation of the required plane. Now you can take it on the one side and write it in simplified form. But actually this is not one plane, there are two planes here. because there are two angle bisector planes, as I told earlier. One is the bisector of this portion, one is the bisector of this portion. So plus will give you one of those planes, which is the angle bisector plane, and minus will give you another one of the angle bisectors plane. So this was all for this lecture, students. I hope you got the point here, and you can apply anywhere in the similar situation. In the next lecture, we will come to some new topic of three-dimensional geometry. Till then, all the best and keep learning.